Hello, I'm Smile. Just last night, Qwen-Image also open sourced this new Qwen-Image layer. This image layering model. What about this model? Can decompose an image into multiple RGBA layers. You can find it from the official project homepage. You can see this rendering. This model here can decompose an image into multiple RGBA images. But this model is rather large. We can see that this model has 57 gigaseconds. The converted model also has about 41G. So this model is very large. And last night, when the model was updated, I also tested the effect for the first time. It can be said or it can be said. But there are advantages and disadvantages. And we're going to take you through that. It is a construction of this workflow and some of the problems at this stage. We still come to our running hub first. We come first, a text-to-image layered workflow. What about this workflow except for our latent node? And the latent at the back cut to batch. In addition to one such node, the rest is normal with us. How to build Qwen-Image text-to-image? Is it the same? What about this latent one here? It is a video used. A node in shallow space. Here it has one more property, which is this length. What does this length mean? I mean, we generate an image layer by a layer. For example, I wrote 21 here. It has 5 layers. 6 images were generated. Here, these 6 pictures are with one of the original pictures. Then add the resulting 5 decomposed layers. So the total is 6 picture and then the words of this model. Except this clip is universal. Our master model, it's a new model with this VAE. Then the parameters are here. The official recommendation for this parameter is 50 steps. Then say, FG is 4. Use this official parameter to run. Is able to generate a better result. We use the official recommended parameters to run here. Will be very slow, because after all, this model is relatively large. We run a graph, run a picture, normally. I use 2.4G in this cloud. You have to run for 10 minutes. And this text-to-image effect. It's not particularly ideal. I can show you the effect. You tested before. Run a text-to-image poster. The words of his text-to-image performance. Still relatively bad. So this text-to-image. I don't think there's much more to say. Because even if we use it, basically not used. This function of text-to-image. So let me give you a brief introduction. This process. After introducing this method of text-to-image, let's take a look at this. The construction of this workflow for graph layering. This workflow, just by uploading a picture from us, then pass it into the model. According to the split number we set here. Then generate a corresponding split result. And we can look at some of these. The effect generated by this image. The layering effect is still very good. What about this picture? In comparison, this effect is still very good. This model that we've shown you before. Because the official model is relatively large than the official recommended parameters. That's a lot longer. So, run very slow. Where are we? You can also try to use it. Our previous Qwen series. This accelerates LoRa. Its speed will be increased several times. But what? The result of this increase in speed is the image we generate will be blurry. Then there will be a serious deterioration. This is a result of my local run. We can take a look. After using this to accelerate LoRa, first this image will cause a serious deterioration, and the resolution is also relatively low. So, I still don't recommend everyone to use this to accelerate LoRa. And then this graph generates this workflow. There is another place. It's about us. We have this positive and negative keyword here. You can write or not here. We can all. get a corresponding hierarchical result. I've added a reverse node here for you. And what about this backstepping node? Here's a system prompt. It is provided in the official code. A system prompt. This system prompt, word, reverse our model. A constraint was placed, a property from this image we uploaded. And then there are the visuals, the environmental details, and the text content on the uploaded picture, etc. There is a constraint in this regard. We can take a look. The keyword deduced backwards. It is normal with us, and there is no system prompt word. Go backwards. The resulting effect is different. We can see the inverse Q. For the elements above this picture, did you give a detailed description? As I told you before. What about this model? It doesn't work with directive prompts. But our normal natural language references, it can have a certain function. By using a reasonable system prompt word, can significantly improve image decomposition and accuracy. So IQ, word. When we use this model, it is still necessary to write it down. That's pretty much it, the main content of today's video. So let me just give you a summary. What about our model of Qwen-Image-Layered? There are two modes of text-to-image and graph. Text-to-image slip of the tongue. At present, the quality generated by the test is relatively poor. The improvement for us to use is not very big. Mainly this pattern of graph generation layering. And this graph generates this pattern. You also showed you an effect of this image. And we use accelerated LoRa. Will generate results for us. It has brought about a more serious deterioration and impact. And we use a high-quality backwards keyword. Yeah, we're going to lay this piece. On accuracy, there is also a better promotion. However, since this model has just been launched, the advantages of this model are obvious but the same. At present, the restrictions on use are relatively large. We hope to continue our community. Can it bring some updates and improvements in use? And what about our video content today? There we go. You can also go by yourself. You can also try it yourself. Okay, see you in the next video.